Hi, this is Vinay. Today I'm going to explain about our project. We are from Team Chiefs. So our project title is detecting web attacks with end-to-end using deep learning model. So and the title itself is descriptive, which says that our model will help in predicting the web attacks. So now, what is web attacks and what are the advantages or why what happens when a website or a application is attacked. So web attacks are common nowadays, which are done by the hackers or the web attackers. They run in an application or they come into an application or or a website and they they steal the data of their customers, or they might even steal the data of their company or an organization. That is illegal. I would say that it's against the company's policy. So what exactly or why they do is that, why the web attackers or the hackers does the web attacking might be, uh, they might demand for the huge amount of money, or else they might even ask for the bitcoins or some kind of digital uh, amount. So we know that in the recent times, these web attacks are highly increasing. So where if you take for a company, like in the recent times, there was a cyber attack or web attack on a company called Indigo, which is a aeroplane company, where the web attackers or the hackers have taken the details of their passengers. So what happened in the here it was the details of the passengers, like name and everything is fine, but they have stole the information of the uh, passengers payment. For example, if a person has used a credit card or a debit card for his payment, so those details are also uh, stole from the company by the attackers. So they can use this card details or everything for the other transactions that is against the uh, uh, company's policy, because for every company or an organization the data is a key, where any uh, misuse of this might always cause an issue to the reputation of the company. So what exactly our product does is that it will help in detecting the web attacks. So in there are several existing implementation of this web attacks. So those existing implementations of intrusion detection system usually extract the features from the network packets or string characteristics of input that are manually selected as relevant to attack analysis. So manual selecting of the features, however, it's a time consuming and requires in-depth security domain knowledge. So it's a large amount of it requires large amount of label exumate and attack request data are needed by the supervised learning algorithms to classify normal and abnormal behaviors. So what exactly our model does is that here we are using the RSMT. RSMT stands for Robust Software Modeling Tool. So what actually it does is that it will automatically monitors and characterize the runtime behavior of the web application. So here it will the RSMT will train a stacked denoising autoencoder to encode and reconstruct the call graph for end-to-end deep learning. Then here we will be analyzing the results of the RSMT with various different algorithms that we are using, like SVM, Naive, or autoencoders, or the LSM, LSTM. So here even we are comparing it with the different algorithms as well. So in this model, we Analyze the results of empirical testing RS70 on both synthetic datasets and productive applications with intentional vulnerabilities. So our results show that the proposed approach can efficiently and accurately detect attacks, including SQL injection, cross-site scripting, deserialization. So these are all the different kinds of attacks, and our model will help in predicting these kind of attacks as well. So now let's move on and see how the model is or how the application is, and then I'm going to explain the code. So now let's see how the front end look like. So here we are using the command prompt. So when I click enter here, this is how our front end application looks like. The title, detecting web attacks with end-to-end deep learning. This is our title, and these are the different options. So first thing is that we need to upload the data set. So here I am uploading a data set, and here we can see this is the file path, and here at the end we can see loaded. That means the data set is uploaded. Now let's generate train and test model. This is train and test model. Now we'll run the SVM algorithm. So here we can see when we have run the SVM, we can see these are all the different comparative features. So here we have accuracy, we have precision, we have recall, we have F-score. So for FCM, we have 50% accuracy, 0.5 precision, recall 0.5, F-score is 0.5. Now let's run the naive Bayes algorithm. So the naive Bayes accuracy is 50, precision is 0.5, recall is 0.5, F-score is 0.5. Now let's run the proposed autoencoded deep learning algorithm. That is what it makes unique from the different model. So here we can see that accuracy is 93, precision is 90, recall is 0.9, X-score is 0.92. When compared to others, this proposed autoencoded model will is perfectly all right in terms of accuracy, precision, recall, F-score. So now we will run the extension LSTM algorithm. So extension LSTM algorithm also has accuracy of 191, precision as 0.87, and recall as 1, F-score as 0.9. Now precision comparison graph. This compares between the different uh, algorithms. Here we can see SVM precision. It's somewhere the precision is around 0.5. This is also around 0.5. Whereas for autoencoder precision, it's high. That's around 0.92, and for LSTM it's 0.91. Then we check the recall comparison graph. So this is the recall comparison graph. So we can see that the recall is highest for the LSTM, and for autoencoder it's around 0.9. F-score comparison graph. So this is the F-score comparison graph. So for LSTM, we can see it's highest and 0.98. So this is how the model, our how the results of our models are. Because we know that every model, uh, the performance or the evaluation is done by these four key methods: accuracy, precision, recall, and F-score. So here we can see for the extension LSTM algorithm, we can see that everything is good. The figures or the numbers are highly acceptable. So now let's move on to the code. So this is the code that we have written with in Python. That's a .py file. So first step here or everywhere is in this model is importing the required library. So here we are the front end that we have seen just now. Here we are using the front-end application, we are using the library TK inter. So what exactly is TK inter? So this is Python's what we call a front end or a graphical user interface package. So it is not only GUI programming toolkit for Python, it is, however, the most commonly used. So what exactly it provides is that it will help the developers to develop the front end application by downloading or by using or by importing several files. So here from the uh, TKINTR, we are importing the message box. We are importing star. That means we are importing everything, and then we are importing the simple dialog. And we are importing from TKINTR. We are putting the file dialog, and from TKINTR dot file dialog, we are importing the ask open file name. Then we are importing the matplot.pyplot as PLT that is used for plotting of graphs. Then we are from sklearn, we are importing the accuracy score, and then we are importing the train test split. It is used for splitting the data into training and testing. We are importing the STM. Then we are importing the pandas as PD. The pandas is used for performing the operations in the arrays. So then we are importing the sklearn.metrics. We are importing the fun score, recall score, precision score. We are even importing the label and good. These are all the different uh, things that we are importing from the sklearn. And from the keras we are importing the sequential. We are importing the dense. We are importing the LSTM. We are even importing the numpy for performing the operations, statistical operations. We are importing the math, and then here we are just passing the tk inter.tk to the main. Then here we are giving the title, detecting web attacks, and the geometry here 1300 cross 200. It's the dimension uh, of the application. Now here we are creating the global classes. So global file name, class path. These are all the different classes that we have created globally. Next. Uh, we are using a definition upload data set. So here we are uploading the data set. For that we have used the global file name as a variable. Then by using the file dialog that we have imported from the TK INTR, we and we are using the ask open file name, and here we are uploading the data set. Then here we can see that once the data file is uploaded, we are adding it with loaded. So once it is successful, we can see that the uh, file is loaded. Then we are creating a function for the prediction. So here we are using the X test class. So here we are using the X test for the prediction. So this is for the prediction. Then for the accuracy, we are defining the another function called accuracy, where we are using y test, y prediction, and details. So here we are calculating the accuracy by using this formula, accuracy score of y test, y pred into 100. So what is y pred? Y pred here is that this is the predicted data of the X test. And next we are building a function called generate model. So here we can see, here we are using the global variables x train, x test, y train, y test. Then we are loading the data. Here we are splitting the data into training and testing by using the train test split function into x train, x test, y train, y test. And here 80% of the data or 0.8 size goes to x to x test, and for y test it goes to 0.2. Next, we are building a function SVM algorithm. So here we are using the global variable classifier SVM precision, SVM X score, SVM recall. So here we can see text.delete 1.10 comma n. Next into CLS is equal to SVM that we have imported from the sklearn. We are giving C equal to 2.2, gamma is equal to square, kernel is equal to RBF, and random set is equal to 2. Then we are fitting the function or the training the model with xtrain and ytrain. And for the prediction class, we are giving the prediction data x text to CLS. And classifier, we are passing the CLS into the classifier. And for the accuracy, we are using this CL underscore accuracy of y text comma prediction data comma SVM accuracy by 2. This is the formula that we are using for the accuracy. And for the F score, we are using F1 score of y test comma prediction data by 2. For precision, we are using the precision score of y test comma prediction data by 2. SPM recall, this is the formula that we are using, and we are displaying the results of everything of all this accuracy, precision, recall, and F score. Next, we are building the definition naive bias. So similarly, as we have done for SPM here as well, first we are using the global variables, naive precision, F score, recall. So here as well, we are training the model, and we are using the fit function. Next, we are predicting the data by using the X test. Then we are writing formulas for the accuracy, F score, precision, recall, and we are displaying the data. So similarly, it is for the auto encoder as well. So this is for the auto encoder. And we are plotting the recall graph, we are plotting the F score. So here we can see the whatever the content that we are seeing, the font and everything. Here, this is the title, detecting web attacks with end-to-end deep learning. This is the title, and here we can see it's bold, and the font is Times, and the font size is 16, and the it's a bold format. So this is the font that of the front end. So this is for the uh, each and every option on the front end. So what we have done is that instead of writing the code multiple times, we have just used the font one. So and we have passed the font one to every button on the front end. So this is the code. So that's it. Thank you.